Agilent's FieldFox microwave analyzers provide full 2-port vector analysis with 12-term error correction from 30 kHz to 26.5 GHz in an instrument weighing less than 3 kilograms. And the results are so accurate, you'll find they correlate superbly with the same measurements you'd make on your benchtop VNA. Let's start by sweeping this tunable filter I have here. If I press the Cal button, you'll see we have 3 calibration options: the simple response calibration or normalization, the quick cal, where we don't need any calibration kit at all, but in this instance I've decided to use the full mechanical calibration. That's a short open load through for the ultimate accuracy. And I've used one of these very cute 4-way Agilent cal kits that fit very conveniently in the FieldFox carry bag that have an open, short, a load, and a through these connectors here. I'll press escape. So using the mode button, I've selected network analysis. And using the frequency button, I've set either a start and stop or a center and span for the frequency range. And by pressing the scale amplitude button, I've set a scale of 10 dB per division and a reference level of 0 dB. So the top reference line of the display is showing 0 dB insertion loss. I can of course press the marker button, and as you'd expect we've got 6 markers available. I've just got a normal marker on the screen at the moment, marker 1, which you can see is at 1090 megahertz and an insertion loss of 1.272 dB. Now of course, pressing the measure key, we're measuring S21 insertion loss, but I could have selected S11, S12 or S22, and of a range of formats you'd expect to see on a vector network analyzer. So we could measure log mag as we are at the moment. We could measure linear, VSWR, phase, a Smith chart, and if I press more, we could look at a polar diagram, measure the group delay through the filter, the unwrapped phase, or just look at the real and imaginary parts of the filter's insertion loss. Another thing you'll immediately see on the FieldFox is the excellent dynamic range. Here, without any effort at all, we're easily measuring more than 100 dB down the skirts of this filter. And if I press the bandwidth button, you'll see I've only had to set a 100 Hz IF bandwidth in order to do that. Another useful feature with the markers, if I press the marker arrow button again and go marker search for bandwidth and put tracking on, you'll see that the FieldFox has put 3 markers on the display here and is automatically measuring the bandwidth of the filter, which you can see is 15.78 megahertz. The center frequency is 1.09 gigahertz. The Q factor is 69. The minimum insertion loss is 1.28 dB. And you can see the frequencies of the left and right 3 dB bandwidth markers. And amazingly, as you'd expect with a benchtop vector network analyzer, if I press the trace button, we've actually got 4 traces available here. Currently, I've only got 1 trace displayed, but if I press the number of traces button, I can select all 4 to be displayed on the screen at the same time. So here in the top left, we've got trace 1, still measuring the insertion loss, S21 of the filter, but in trace 2, I'm measuring S11, the return loss of the filter. And you can see the same 3 markers are still present on that display as well. On trace 3, I'm displaying a Smith chart, so we can measure the impedance of the filter at the range of frequencies that we're sweeping. And in trace 4, I'm currently measuring group delay. In all 4 traces, I'm measuring the forward S parameters, S11 and S21. But as you saw under the measure button, we can also measure the same for the reverse, S12 and S22. I'll press the trace button and go back and just display trace 1. What's especially surprising on a handheld vector network analyzer is the ability to set limit lines. If I press the limit button, you can see here, if I now edit the limits, we can create a table here quite easily with a series of pass and fail limits with start and stop frequencies and amplitude levels that the filter must pass in order to give the operator a pass indication or a fail indication. But if we have a perfectly tuned device, as we do with this filter here, I can ask the FieldFox to build the limit lines automatically from this trace. It'll treat this filter as the golden standard. Here you can see it's created the table of limit lines. I'll exit from there. We'll turn the limits on. And under options, I can set a margin here. So if we say this filter has to look like that shape, but within 2 dB, and I turn the warning indicator and the beep on, you'll see that the filter obviously passes because this is the golden standard. But if you have a technician or someone out in the field who has to tune up these filters on a regular basis, you can save these limit line settings, recall that, and then the operator just has to adjust the filter until they get the pass indication on the screen. And of course, the results can be saved to the internal memory, USB memory stick, or the SD memory card. In this example, I want to show you how quickly the FieldFox can be set up to make a quick measurement, in this instance, the return loss of this microwave horn antenna. I'll press the preset key and mode preset. That puts the instrument back to its factory default state. We'll set a frequency from, say, 1 gigahertz to 12 gigahertz. And I'll press the amplitude button. We'll set the reference position to 0, and the reference level is 0 dB, meaning that the top line on the display is 0 dB. The scale is 10 dB. I'll just change that to 5 so we can see a bit more detail of the return loss trace. Now, you'll notice I haven't done a calibration here, but the FieldFox has a feature called Cal Ready. That means that when you buy the FieldFox, it has been pre-calibrated at the Agilent factory for this point here. This reference plane here on port 1 connector has been calibrated across the entire frequency range of the FieldFox. So with a short high quality test cable such as this, I can connect the antenna directly to the instrument, and you can see immediately, if I press the marker button here, we've got a marker on the screen, we're immediately measuring very accurately the return loss of this antenna. Let's line that marker up with the minimum, and let's turn on another marker and perhaps move that across to this minimum here. And another nice feature on the FieldFox, there's a marker table. You may be able to see there the marker 1 frequency and the return loss, and marker 2 frequency and its return loss. So in just a minute or so, we've made an accurate measurement of this microwave horn's return loss. And of course, at any time, we can save the screen image to the internal memory, an SD card, or to a USB memory stick. We can save the trace data to a TRC or CSV file for later recall and comparison. And we can save all our instrument settings to an STA state file, also for later recall, making it easy for less experienced folk to make accurate and high-quality VNA measurements every time. For further information on the FieldFox Microwave Analyzer, please contact your local representative or visit the website shown below.